Hello everyone, welcome to the EasyPower Refresher webinar series. My name is Jim Chastain. I'm a solutions engineer at Bentley. My focus is EasyPower software, and I appreciate everyone joining us today. The title to our discussion is Two Problems Solved with Custom Arc Flash Labels. I want to emphasize this is not a discussion on how to do labels. This is more a solution resulting in modifying arc flash labels. And if you think of it that way, there are a number of ways you can address problems you have with your on-the-ground system at the site if you better understand how the label situation is managed. So with those kind of forewarning, as we're in the habit of doing, I'd like to start off with a couple poll questions. And there's no obligation or liability, just trying to get some feedback from the audience at the beginning of this. So how often do your projects require custom arc flash labels? And I realize there are times when the standard label is fine. We have 36 different templates that you're welcome to use if they solve your need. So we're about halfway to a quorum. Let's give this another 15 seconds. Again, we appreciate everyone joining us today. There will be a certificate of attendance sent out via email based upon the amount of time you've attended. You should receive that by early next week. Okay, looks like we have a quorum. Here's how folks have weighed in on this. So, interesting distribution. The middle of the curve looks like a couple times a year the users, and then never, and then more than a couple times a year. So fair enough. And then my second question is, how do you rate your custom label skills? Again, this is feedback just for me. It's not going to be stored in a database anywhere. I do encourage folks to try out the label editing software before you actually need it, but because there's a lot that you can develop in terms of just a basic label generation if you try it out before you have a fixed schedule on a project. Okay, so this looks like the quorum's been reached. Almost same distribution, but it looks like a few more beginners, so you've come to the right place. So just for a starting point, when you start to edit a label template, make sure after you open it up, you save it as a different name so you don't contaminate the template itself. And so it's just a word to the wise. You don't want to overwrite one of the existing templates if it's useful for other reasons. The examples I'm going to show are a little bit rough as far as the alignment of the different elements, and it's relatively easy to use a pixel count to position the replacement text or variables. I'll show you where that is. I'm not going to take the time to do it on my examples. But what you'll see is the ability to use conditional logic to control the values that are used on the label itself. And therein lies some uniqueness as far as what these tools can do versus typical label printing software. And then ultimately use the visibility logic to control specific events. And I'll show you, although I didn't use it in these cases, I'll show you what I'm talking about. And just a word to the wise, it's extremely useful. Okay, a couple words about the device code. The device code as an element in the database is unique in that it has a space or an entry point on the specification tab for each bus. It's not mandatory data and it's not automatically filled in. It can be used in the variable list for template properties. And so in this case, we use the device code uh, as a conditional element. And then it is a column that shows up in the database browser. So even though it's not used in any part of the computation of ArcFlash, it's still an interesting element to be able to access, especially with label editors if you need it. Now, with that said, if you've watched any of my videos during ArcFlash label preparation, I've pointed out that I use the device code as the part of the label address for the QR code map. So if you scan this code, this is the URL that will appear. And by using the device code in my one line, I was able to generate a unique address both for the HTML location and for the place in my one line. So device code is a very useful element, even though it's not a calculated value. Okay, so the first problem we want to talk about is a client wants an ArcFlash label at the transformer access door, and he wants the one label to show the ArcFlash PPE for the secondary terminals because that's the side of the transformer that usually has an elevated ArcFlash result. But at the same label, he wants the voltage PPE based on the primary terminal voltage because that's usually the higher voltage requirement or restriction for PPE requirements. Well, the problem is EasyPower has this data on different buses in the ArcFlash hazard report. So it brings us to the one line. So this is a template or an example that I put together just to be able to test the code that I did. But I have the three transformers. I have primary of 34.5 down to a secondary of 480, and then from 480 I go to 208. And then on this transformer we start at 13.8 and go to 480. And for my own purposes, I'm going to generate a label for the secondary based on the secondary calculations, because that's where the ArcFlash is most restrictive or most concerning. So for bus 2, I want the device code. I'm going to use the device code of the primary voltage. The secondary will be 480 volts, and then for the PPE requirement for the primary, I'm going to have a limited and a restricted barrier or boundary, and then the generations of glove class. So let's go to the one line and talk about this. Okay, so if I go to short circuit, fault all the buses, I can see I have my incident energy is okay. It's being calculated for the secondary bus. If I go to arrange for ArcFlash to see the data, I see that all these are transformer terminals, and for bus 2, I have the calculations of the incident energy, and then the description of where the PPE needs to be looked at. So this brings up how to manage the labels. I access the label editor by clicking on the ArcFlash hazard report. That allows me to access the label icon on the top banner, and then from there I select a PPE, or rather a label template. This is where the 3 dozen different templates, mostly arranged by physical size. So the one that I worked on, I'm going to call transformer labels. And what you see is I've just rearranged one of the templates that we use for standard. I left the warning label at the top. I put my vertical separation between the primary side and the secondary side. And now I'm showing primary voltage, the limited approach boundary, the restricted approach boundary, and then the class 4 gloves for a 34.5. I can see that that matches what I'm showing up on my spreadsheet. Well, how did I do that? Well, first we need to go to the label designer and then start the editor. And again, because I started with a typical one line or typical template, the first thing you want to do is to save it, save as a different name, and that's where I got the name for transformer labels. Okay, if we look at bus 2, I can click on each element that's in the display, and the editor for adjusting that will appear in my graphical item edit feature. So if I pick shock hazard, it's a standard text that I can adjust, make changes, move around, but it has nothing to do with the calculations. If I go to the primary side, again, this is standard text, but I have a device code of 34.5, which is again, I take that back. Let me show you where this comes from. So I'm going to discard the edits. I'm going to go back to my one line and talk about basically for the secondary connection, the secondary terminals. I want to look at the database edit. I want to assign a primary device code to that number. So for bus 2, my device code is going to be 34.5. So I put 34.5, which is the primary voltage that's going to be displayed. And that's the only change I made for the bus. Likewise, over on bus 7, it's a 13.8 kV primary, so the device code is going to be 13.8. This is just a static fixed variable that I'm going to be putting. Now, the device code for a 480, I use 0.48 as my variable, and the HTML code had a hiccup with it, so I use A48 in place of the period. Now, if I go back to my short circuit focus, fault all the buses, range for arc flash, now we can go see where that information is found in the label. Go to the label editor, pick out that. So this is the label that I saved, or the title that I saved. I want to edit it. So we go into the label designer and start the edit. And as it sets up, I have the graphic representation of my finished label. And then as I pick each element, this is fixed text. And I can edit through the edit window the contents of that text. So if we want to put an exclamation point, we just type it into the line for the shock. Now again, the primary voltage, I'm showing the value of 34.5, and that's will be shown, excuse me, the 34.5 is the text that will be shown whenever the device code is equals 34.5. And so that's where we're seeing this and the word primary. If I had another bus, let's go to bus 6, it shows for that element device code of 848, 480 volts. If I go over here, so that what a significance is I picked the primary voltage to be the value of the device code. So that's set up in the one-line diagram. And then from then on, I just have from my little table for 34.5, I have a restricted boundary of 6 feet and then a limited boundary of 2'9". So if I go back to bus 2, 6, I got this wrong, 6'4". So I want to make a correction. So it should be 6'0", I think. And literally, that'll change. Now it's correct. And my restricted approach is 2'9". And again, this is static text as long as the device code equals 34.5. So by doing this, now we go to bus 6. My primary is 480. From my little chart, for my 480 bus, I have a 3'6", 1 foot 0 inches for restricted approach. Now on the arc flash side, which is a secondary, this is the value calculated of instant energy on the bus that I've selected. And so this is fixed text, this is a working distance, and this is the calculated working distance from the arc flash calculations. All right, I think I had, so I had one of these have I entered. I want to show you how it's done. So I'm on bus 7. Bus 7 needs a restricted approach boundary, so it should be 2 foot 2 inches. So if I come over here, I'm going to insert text from the top banner. I insert text and it shows up this little item here, says replace text. So I'm going to replace my 2 foot 2 inches, which is a restricted boundary at 13.8 volts. So we just type in the text I want to use, 2 foot 2 inches. Now these are the dials I was talking about, position, location for this element. And right now I don't want it where it's sitting, I want it somewhere up with this restricted line. And then if I want to make it match up the rest of my label, I toggle between, well, in fact, I just showed an error that I've overlooked so far. When I went to the bus 6, it's showing both the value I just entered and the one that's correct for the, so I want to make this display conditional upon the device code equal to my device code for bus 7 is 13.8. So now this is only going to display when we have 13.8. But the point I was trying to make, now when I go back to bus 6, this Okay. Well, I've tripped myself up on my own documentation. The point I was trying to get to, oh, I was using a default, is that the dial settings for this entry are 3.4 and 2.39. If I go back here, I can put those same dial entries in this one and line up perfectly. Okay, so the point being, when I have an exclusion, in this case, when I entered the value for 5'0", it's done so when the device code equals a certain value. When I set that up as an original concern, there was a default value there, and I needed to remove the default value so that when this command, when the device code is some value different, it doesn't put up an extra value. Okay, so that wasn't quite as smooth as I was hoping for. Any questions about that? Thanks, Frank. Frank's saying he uses volts instead of kilovolts. This way you won't have decimal variables. Good advice. Thank you. Okay, so I thought this was a pretty elegant solution, and it only applies to transformers. That was the only restriction, because without seeing the rest of his one line, I'm not sure what's going to come up on a regular bus. Okay, so with that, I save the template, close it, and I'm ready to go on to the next problem. Okay, so there's an issue with when you do a artificial max time adjustment. There's an indication on the spreadsheet that doesn't list the upstream trip device, which is normally what tells us the fed by value. And so when I have a manual fixed time of 2 seconds, it's going to, especially on the low voltage buses, it's going to interfere with my ability to put things on the label. So the solution, the potential solution, one of the solutions would be to use the device code to patch around those indicated locations. When I mean patch around, I'm talking about artificial, or just using the device code to say, hey, no, this is the upstream device no matter what's happening. So let's see if we can't find that one. So this is just part of the bigger picture, but I'm just going to worry about this bank of panels down here. When I go into short circuit focus, fault all the buses, I get very high value when my setup is even at 2 seconds. But the problem is it doesn't show what my location of the breaker is. It just says manual time is doing the limitation. This brings up another question, and something to think about if you're a label editor. That is, the manual time, the 2 second max is calculations for arc flash, and so you don't get an indication on which breaker is going to trip as long as it's being interrupted at 2 seconds. But when we're talking about protection for somebody working on this bus, they're not going to be subject to the arc flash limitations for protective devices. They need to know what the upstream device is, whether it's arc flash calculated or not. So with that said, I'm going to make this be my upstream device for those particular buses. So let's kind of do that. I can just go back to database edit, take the breaker, copy the ID name, open the panel, put this in the device code. The problem here is the voltage is lower when we go through a transformer and doing arc flash calculations. So there's going to be a max current limit no matter what. If I'm going through a system with primary protection only. So again, now I'm just going in and putting device code with that upstream ID. Hoping I did that in the right place. I can't talk and click at the same time. Yeah. So now for each of these device codes, I want to put that in as my constraint for the label editing. So now we go to short circuit focus. Focus these 5 buses. Look at the spreadsheet. Now I need to write this down somewhere, but I haven't done that so far. Look at the label editor. And I think it's this one. Then go into the design labels, start the editor. And for the first ones, which is LA, you can see the code is already set up. When the device code is not blank, then fed by device code is the entry I want on this label. Likewise here, if the device code is not blank, and I want it fed by the device code entry that I made on the one-line diagram. We didn't change that guy, but we changed this guy. This guy was on another. We may want to go back and change him. So anyway, now, because the upstream device is not being identified by the system, we are artificially patching around by using the device code. Any questions? Chuck's saying, if you have an inverter, can you show the voltage to be DC? All the levels I've done with inverters do not allow the differentiation between AC and DC on the label. I think the answer is yes, Chuck, because we would just, well, I shouldn't be quite so glib. I can identify with my database, I can identify an AC or a DC bus. And from that, I need to work out the logic it would take to be able to select what entry I want to make on the label. And then maybe I have a different field. Yeah, I'd be interested in kind of playing with that. Chuck's asking a good question. I haven't done it, but I'm up to the challenge if you've got questions. Okay. Any other questions on? So again, the device code is the key to doing a lot of neat stuff without having to recalculate your whole one-line diagram. And in these cases, all I did was add the device code with whatever breaker I wanted to point to. And if the value, and it's conditional upon the device code being there for the value to tell it whether or not it's going to be. In fact, it's going to always use the device code for my display on that particular bus. Just the way I've set it up. Okay, any other questions? Now, so these are just two relatively straight solutions that it didn't take that much to work out the logic involved, but it gave me pause in how valuable this variable is because it's accessible by so many displays that we have both in the one line and on the label. So that completes what I have today. I would maintain that the label editor makes it easy to customize labels, easy to make a professional label, even though you're a small operation. I would encourage you to try different things, and if you've got questions, you're welcome to contact support or me, and I'd be happy to walk you through it. Thank you everyone for joining today, and we'll talk to you down the road.